Welcome everybody to my presentation in this EBRO 2020 meeting. First, the organizers for me to this meeting. I hope in future meeting we can see all each other in person. What I'm going to today is animal models related to neurodegenerative diseases. So is one of the projects was published from our group related to anxiety, depression, and learning behaviors from post-traumatic stress disorder animal models. So hoping to cover like the most or the highest number of animal models related to that. So this presentation will go into introduction, hypothesis, methods, conclusion, discussion, finally future recommendations. So this work we're doing is learning and memory, and how they are impacted factors, drugs, conditions, and diseases. So learning and memory are closely related concepts, but they are distinct. Whereas learning is the process in which we acquire the knowledge, memory is the process in which information is encoded, then later retrieved to be utilized when needed. So memory, and I'm talking the limbic system, not in terms of the cortex, is divided into short-term or can be divided into short-term memory and memory. So the short-term memory in this context is the one that lasts few minutes up to like 2 hours. The long memory is longer than that. It starts from several hours, 4, 5, 6 hours, going through into lifetime if we go and include the cortex of the brain in the context. So the part of that we are most concerned about is the hippocampus. Various brains are involved in memory, but here we're talking about spatial learning and memory, and that's where the hippocampus comes into play. So it's a major organ for remembering, and it's helped in learning and memory. Now, that we are concentrating on is one like the one we utilize when you park your car in a garage. You have to use your memory to come back and find your car in the space of that garage where you have parked it. So when a taxi driver has to find an icon in a city from a different direction, like he knows from the south to locate it from the north or from the east. So this is the kind of memory that we are talking about here. It's the memory with spatial orientation within the complicated space, I would say. So diseases and conditions are tested in our groups, and that leads to impairment of memory function includes Alzheimer's disease, vascular, hypothyroidism, sleep, consumption of high-fat, high-carbohydrate diet, or what's called chronic stress, obesity, and lately post-traumatic stress disorder, which I'm going to concentrate on today. And we need drugs, pharmaceuticals, and even plant extracts to work these conditions, including nicotine, thyroxine, and many antioxidants like pentoxifillin, caffeine, vitamin E, vitamin C, melatonin, L-carnitine, Timpol, folate, cerebrolysin, idarapon, and omega-3. Also, we have tested a number of plant extracts that are rich in alkaloid content, which have strong antioxidant activity as well. As I said, today I'm going to take the money project to present animal models related to it. And that project is on the of a new drug called itazolate on anxiety, depression, and memory and learning functions following post-traumatic disorder condition in animals. So to give you a background about post-traumatic stress disorder or PTSD, prevalent neuropsychiatric disorder. It presents after a person experiences a traumatic event. PTSD has a lifetime of about 10%, and symptoms usually include intrusive relocation of trauma, avoidance, event reminder, hyperarousal, other comorbid conditions such as anxiety, depression, and deterioration and learning. Treatments are not optimal for this disease, and that's one of the just why research is still to find and to identify better treatments for this anomaly. The drug that we are considering today is itazolate, which is a phosphodiesterase inhibitor, type 4 inhibitor. It's important in pharmacology. It has anxiolytic, antidepressant, and memory-enhancing properties. It's as well antioxidant and anti. The aim of this study that I'm presenting was to evaluate of preventing anxiety, depression, and cognitive dysfunction induced after PTSD condition. To point out to some molecular targets of the or possible molecular targets for the action of that drug in PTSD. So we used adult rats, which were randomly assigned into 4 major groups. Grouping was 4 groups, which were vehicle, itazolate. That group was given the drug, 1 milligram per kilogram. Post-traumatic stress disorder group, that group was exposed to that produces that is similar to PTSD behavior in human, but produces that in animals. So it's produces PTSD behavior, prolonged stress paradigm. Then the last group was exposed to the SPS sign, sustained to induce PTSD-like behavior, and was as well treated with the drug. So this lasted for 5. Then the animal testing was started. So this is the experimental time course. Animal was conditions of the lab for 3 weeks. Then they were treated with itazolate. Later, the SPS, which induces PTSD-like behavior, was instituted. itazolate was day 49. Behavioral testing was started. So this is the sustained prolonged stress paradigm. It consists of 4. Step 1 is immobilization of the animal for 2 hours via restraining the animal into tight restrainers. Second step is forced swimming in a closed container or in a cylindrical tank. Then the animals in the third step was allowed to recapturate for 15 minutes. Finally, they were exposed to either for 1 to 2 minutes until loss of consciousness or until loss of consciousness. So this paradigm is proven to induce a PTSD-like behavior in animals. We tested anxiety using a number of models. Number 1 model was the elevated plus maze. As you see in the picture, it has 4 arms. 2 of them has high walls, so they are closed. And Two others does not have walls, so they are open arms. So what's being quantified is the interest to the open versus by the animal, along with the time spent in each arm, closed versus open arms. So the animal that will be fearful, so he will prefer the closed ones, whereas the one that does not have anxiety will go more likely to. The second paradigm that we used to test anxiety was the open field test, OFT, an open area. It's just an open glass box, and the base of the box is divided. Now, what we have measured, or what we are measuring, is the number of squares crossed by the animals left in the box for 15 minutes. So you quantify, you of course videotape everything, and then you score. You quantify the number of crossings, you quantify the time spent at the center of the box, at the central squares, number of by the animals. That's when he stands on his two rear feet, raising the front to. That's an exploratory behavior, the animal. The grooming time in grooming. So animals that has heightened anxiety will have less exploratory behavior in general. So that's basically the idea of this. Depression was testing via tail suspension test, and tail suspension test is a picture. The animal is hanged by its tail from a table or a raised object, and it's left hanging there. It's been quantified time during the hanging period, which went up to 6 minutes. So as if the animal freezes, the depression-like behavior. Finally, we tested learning and memory are tested using mazes. The paradigm that we use is called the radial arm water. A circular cylinder water tank. So this is all water. And blue one, of course, has a round central area and 6 radiating arms from that. One of the arm on the top that has the dark circle does have a hidden platform capable that color and it's invisible for the animal. Now these animals water, so not like to escape the water. So that's the only escape. So what we do, the animal is in that at one of the arms, just random arm, other than of course the arm that has the escape. So the arm where the start arm, and the animal is given 1 minute to explore the maze. Of course, he will go in naturally, and he will be escape platform. Now, this whole thing is a one learning trial. So that's training, a one training session, if you want. We do that for the animals 12 times. 12 trials of 6, then trials, then 5 minutes rest, then another 6 trials. This whole thing is a learning experience. And in each trial, we count the number of entries that the animal does to arms that does not the goal. First fixed. Because the animal does not see the goal, he will use the cues. So we intentionally use for the animals, such as pictures, objects, etc., that are fixed. So the animal will use these cues at the hidden platform. Next task, he will have to locate the hidden platform from a different arm or a different direction. So as now, first few trial would be kind of meaningless in terms of learning, but once the animals start to develop their behavior experience, it will there are animals who will learn faster than others, and that's an indicator of the learning process. Now, memory after that, you wait for it, then you put the animal from any start arm and you count the number of errors until it finds platform. So we did the testing at 30 minutes, which is the window of the short. We did other 5 minutes and 24 hours, which is the window of the long-term memory. After they sacrificed the animal, we killed the animal, took the hippocampus out, and measured new factor, BDNF, neurotrophic factor, which is the most important neurotrophic factor in the adult brain. Then we also measured stress biomarkers, excited dismutase, glutathione peroxidase, catalase, glutathione, reduced glutathione, and citric acid reactive species, TBACs. So these are all markers of oxidative stress. So that we are targeting here, if that drug and that condition is interplaying around the oxidative stress pathway, around the neurotrophic pathway. So these are the results of the learning, are motor maze. So the y-axis is the number of errors the animal committed in each trial, as the x-axis is that you see 6 trials, then a rest period and another 6 trials. So the animal start by making a lot of errors, then with more trials, the number of errors in all groups start is a normal learning. Now, what you can see here that the groups are not different. All of them are learning with this, I would say. So there is a learning process among the animal groups. So PTSD did not affect learning and memory, as well as it did not do anything for memory. Okay. So here is the memory now. As I said, we tested short-term memory at 30 minutes, long-term memory and 24 hours. Again, the y-axis is the number of errors committed by the animal, of course, errors. Axis is the groups: control, etazolate, PTSD, post-traumatic stress disorder, exposed to SPS, and both. So as you see in A, the short-term memory, the PTSD animal group made significant errors compared to the other, indicating that PTSD impaired short-term memory, whereas when PTSD late was added and taught, or when they were instituted together, I would say, the number of errors was normalized. Similar results were 5 hours long-term memory, as well as 24 hours long-term memory. PTSD impairs this memory, and late was able to keep it normal. This shows part of the elevated plus maze, which is we use to quantify or to measure anxiety. So A of enters into an open R. B is the percentage of the time the animal enters. It's a reflection of almost similar measure. C and D are number of entries as well as percentage to a closed R. So you would notice that the PTSD group made significantly less entries to the open R and percentage of entries to the open R. Whereas when etazolate was in PTSD, the number of entries to the open arm was similar to the control group. So this indicates that with PTSD phenomena are more reluctant to get into the open air, getting a higher level of. Now, we found also, look at D, we found also that the percentage of entry to the closed was also in the PTSD group, normal when etazolate was added on top of PTSD or PTSD with rate. And number of entries to closed arm were not significant, but that don't get perfect data all the time. But collectively, this indicates heightened anxiety in these animals. When we count time spent in closed arm, all groups were similar. So we couldn't find consistent data with those of the numbers. Again, this is here the open field behavior. As I said, we measure the time spent at the step, indicating more exploratory, ambulatory activity, which is exploratory. Time spent grooming, which is again in lower anxiety. The animal is more relaxed in the content. Number of rares, which is exploratory. Freezing time. So time spent in the center was significantly lower in animals that had PTSD-like phenomena. Ambulatory behavior was lower, and time spent grooming was significantly lower. It isolates all of these. So again, there is an indication of higher anxiety behavior in these animals, and etazolate is doing some normalizing that. Now, this is the depression-like behavior test, the tail suspension test. So here, we measure time, or the immobility time. Mobility time, the more depression-like behavior in the animal. Again, the PTSD had significant increasing time or immobility time compared to other groups. PTSD plus etazolate was normal. So there is depression, like etazolate is normalizing or restoring that. Molecular data. So it's here we look at the oxidative stress biomarkers as well as BDNF. So the panel on the left is the glutathione, the glutathione, GSH. So levels is on the y-axis and the groups is on the x-axis. There is reduced glutathione, which indicates higher oxidative stress level because this is that's actually neutralize the free radicals that causes oxidation. Thiobarbituric acid reactive species were higher in the PTSD groups and indicates which is another form of oxidative stress related pathway. So PTSD peroxidation normal when ETZ treatment was instituted. DSSG, which is the glutathione, far panel in the upper right, is higher in PTSD group, and this is the bad news that results when gluten neutralizes the free radicals. So it's higher in the animals with PTSD as far when etazolate was. The glutathione peroxidase, which is the capacity enzyme that's in the oxidative stress gain, is reduced in PTSD group and normalized when PTSD and etazolate was given together. Finally, the brain neurotrophic factor, which is the other pathway, the neurotrophic factors related pathway. It is lower T group and etazolate normalized this. So taking this data together, the SPS model of manifests characteristics of anxiety, depression, and memory impairment as major comorbid characteristics of PTSD. Etazolate was able to reduce anxiety, depression-like behavior, and memory impairment with SPS model. This was associated or correlated with restoration of oxidative markers and brain-derived neurotrophic factors. So we can suggest that ETZ is working and that could be oxidative stress and brain-derived neurotrophic factor-related pathways. The future recommendation, we need to follow up and look more into mechanisms, more into even genetic mechanisms and genetic factors, histones probably involved in such effect. Particular work is needed toward this end. This work was funded by research at Jordan University of Science and Technology, Jordan. Other funding to the lab came from the Scientific Research Fund in Jordan, Institute, National Drug Abuse, Fogarty International Center, and San Diego State Foundation, all in this. Thank you very much for your time. Thank you very much for having me with you. And again, I hope to see you in future meetings.